Good morning everyone. In this video, I will be discussing inverse function. So by definition, inverse function is an anti-function that is denoted by f of negative 1 of x. It is also known as the reverse of a given function. So let's have example number 1. Find the inverse of the given function. Given function is above x is equal to 3x plus 2, which is a linear function. Now to do this, we have to first change f of x to y. So it will become y is equal to 3x plus 2. After that, we have to interchange x and y, meaning all x will become y and all y will become x as we rewrite it. So our y here will become x, that is equal to 3, followed by x, it should be y as we change it, plus 2. So we have here now x is equal to 3y plus 2. And the next procedure is to solve for y. So to solve for y, of course our final should be y is equal to something. So in this case, we have x is equal to 3y plus 2. We have to remove this positive 2 here in order to retain 3y. So we have to subtract both sides or add negative 2 both sides of the equation. So it will become x minus 2, and on the other side, this is 0. We have now 3y. So in this case, we use commutative property of addition. Now, for our for our x minus 2 is equal to 3y here, we have to retain y and we have to remove 3. So in order to do that, we have to multiply both sides by 1 over 3. 1 over 3, or divide both sides by 3. So in that case, we can make this equal to 1. That's the right side of the equation. So the right side of the equation will become only y. So the left side will be x minus 2 over 3. We used commutative property of multiplication to solve for y. Now, for the last step, we have to change y to f of negative 1 of x. So our final answer will become f of negative 1 of x is equal to x minus 2 over 3. So this is now the inverse of the given function. For our second example, we have f of x is equal to negative 4 minus 5x, which is also a linear function. Now to transform this into its inverse or its inverse function, we have to, number 1, change f of x to y. So it will become y equal to negative 4 minus 5x. And for the second procedure, we have to interchange x and y. We have to change all y into x and all x into y. Now we have x is equal to negative 4 minus 5y. We have to solve for y. And using commutative property of addition, we can add both sides by positive 4 and positive 4, to remove this negative 4 and retain negative 5y. So in this case, our left side will become x plus 4, and on the other side, we have this 0 minus 5 is negative 5y. To further solve this and isolate y, we have to use commutative property of multiplication. So we have to multiply both sides of the equation by the numeric coefficient of y, but in reciprocal form. So that is y over negative 5. This is also 1 over negative 5. So it will become this will become the right side will become y, while the left side will become x plus 4 as we multiply 1 to each term of x plus 4 over negative 5. So we have here y is equal to x plus 4 over negative 5, and for the last step is to change y to negative 1 of x. So y will become f of negative 1 of x is equal to x plus 4 over negative 5. So this is now the inverse of the given function. For our example number 3, we have the given function f of x is equal to x squared plus 4x minus 1, which is a quadratic function. So we have to do some sort of grade 9 mathematics here, applying the formula of quadratic equation, the procedure of quadratic equation. So to do this, we have to apply the same rule, same first step of the previous example. We have to change f of x to y. So it will become y equal to x squared plus 4x minus 1. Now for the next step, we have to use completing the square on the right side of the equation. How are we going to do that? We have to apply our ax squared plus bx plus c. So in this case, our a is 1, which is the numerical coefficient of x squared, and our b is 4, the numerical coefficient of x, I mean positive 4. If it is negative, you have to carry on the negative here on your b. So at this part of our solution, we are just looking on this part. Okay? So we're just looking on x squared plus 4x. So to continue this, we are just going to manipulate b is equal to 4, the value of your b, or the numerical coefficient of the middle term or of our x term. So in order to do completing the square, we have to divide b by 2 and square the answer. So since b is equal to 4, we have 4 over 2 square, and that will become 4 divided by 2 is 2 square. The answer is 4. So what are we going to do with 4 now? We will be adding this 4 to our equation. So it will become y equal to x squared plus 4x plus 4, the number that we have added, and you have to also subtract that number. So this is your b, and then followed by the remaining negative 1. So this is how it will look like. So we have added our 4, at the same time we subtracted, in order to, of course, balance the right side of the equation. So to continue this, we are now going to factor out the first 3 terms. which is a perfect square trinomial, this part. So we have to factor out the first three terms. So I just rewrite it here. Now to factor this out, this is how are you going to do. Get the square root of x squared, and the answer is x. Get the square root of the third term, which is positive 4, and that is 2. I mean, square root of 4 is 2. And then copy the sign at the middle term. So the sign is positive, so this is positive. Then enclosed it in a quantity but squared. So in this solution, we're just looking at these three terms. So we still have negative 4 and negative 1 to combine, and the answer is negative 5. Now, we haven't interchanged yet our x and y, so now we will be doing that. So the next step is to interchange x and y. So all x will become y and all y will become x plus 2 square minus 5. And then after interchanging it, we have to solve for y, of course. So to do that, we have to remove that minus 5 first on the right side of the equation. So we have to remove this negative 5. In order to do that, we have to use commutative property of addition. We have to add both sides by 5 plus 5. So the left side will become x plus 5 equal to y plus 2 square. And this is now going to be equal to 0. So we have already removed negative 5. Now, our goal is to isolate y, just to solve for y. So at the right side of the equation, you still have that square root. We have to remove that. So we have to square root both sides. So square root both sides. So it will become square root of, let me just rewrite it. So square root both sides. So this is to be cancelled out, square root and square. So our left side, plus or minus square root of x plus 5 equal to y plus 2. So as we isolate y, we have to add negative 2 both sides of the equation. So that is commutative property of equality by addition. So our left side will become plus or minus square root of x plus 5 minus 2, that is equal to y, since 2 plus negative 2 is 0. So our final answer will be, as we go on the last step, change y to f of negative 1 of x. So our final answer will be f of negative 1 of x is equal to plus or minus square root of x plus 5 minus 2. So this is now the inverse of the given function. Our next example, we have f of x is equal to x squared minus 8x plus 2, which is also a quadratic function. So the first step is to change f of x to y. It will become y equal to x squared minus 8x plus 2. And the next step is to complete the square of the right side of the equation. So we are just going to look at the first two terms, the a squared terms minus b squared terms, but actually we're just looking at the term which is just x. So our b here is negative 8. To do completing the square, of course, we have to use the formula b over 2 square. Since our b is negative 8, that is over 2 and followed by square. So let's solve the inside. Negative 8 over 2 is negative 4. And we still have square, whose product is positive 16. So this 16 will be added and subtracted on the right side of the equation. So it will become y equal to x squared minus 8x plus 16 minus 16, then followed by our plus 2. And after this, we have to follow the next step, which is to factor out the first three terms, which is a perfect square trinomial. So factor out. So what we are going to factor out is just these three terms, the perfect square trinomial. To do this, we have to get the square root of the first term, and the answer is x, and then followed by the square root of the third term is 4, and of course our sign to be used in between them is the sign of the middle term, which is negative. So this is negative, and close it in a quantity and write square. And after that, simplify the fourth and the fifth term. Negative 16 plus 2 is negative 14. So now we are left with y is equal to x minus 4 square minus 14. And at this stage of our solution, we have to interchange x and y. So all y will become x and all x will become y. That's minus 4 square minus 14. And after that, we have to solve for y. To solve for y, we have to isolate, of course, y. In this line of solution, we will be using our commutative property of addition. So we have to remove this negative 14 here. And in order to do that, we have to add 14 both sides of the equation. So it will become, the left side will become x plus 14, while the right side is y minus 4 square. And this is already equal to 0. As we continue this, we have to remove this power of 2 here. So we have to make square root both sides of the equation. We have to take the square root of both sides. So we have square root of the right side and square root of the left side. The left side and the right side. After that, we have to cancel out this power of 2 and the square root. The right side will become y minus 4. The left side is plus or minus square root of x plus 14. Now, since we have to isolate y on the right side, we have to use commutative property of addition. We have to add 4 both sides. So our left side will become plus or minus square root of x plus 14 plus 4, that is equal to y, because negative 4 and positive 4 is 0. For our final answer, we have to change now y to f of negative 1 of x. That is equal to plus or minus square root of x plus 14 plus 4. This is now the inverse of the given function. For our fifth example, we will be taking the inverse of a given rational function, that is 4x plus 2 over x minus 1. So we have the same procedure For the first four examples, we have to change f of x to y. It will become y equal to 4x plus 2 in the numerator and x minus 1 in the denominator. For step number 2, we have to interchange x and y, so y will become x and all x will become y. And after this, we have to solve for y. So as we solve for y, in this stage, we have to, stage of solution, we have to, the only thing to do is to cross multiply. So let me just first cross the numerator to denominator. So we have x times y minus 1 is equal to 4y plus 2. So I just cross it. And then we multiply. We have to x times y minus 1 is xy. xy minus x. That is equal to, the right side will remain as 4y plus 2. So we just multiply. Next step is to regroup y. So all terms with y should be written on the left side of the equation. So our xy will remain in the left side, and our 4x will become 4y on the left side, and we write positive 2 on the right side, and we have our negative x will become positive x on the right side. Actually, we used here our commutative property of addition, or just changing the sign of x as we move on the other side of the equation, and 4y on the other side of the equation. So that's the reason why it becomes negative and positive x. Negative 4y and positive x. The next procedure is to factor out y on the left side. As we factor out y, we have to remove all y's in the left side. So we have y, and the remaining terms in the quantity is just x minus 4. We factor out y. So we have x times y is xy, negative 4 times y is negative 4y. And we rewrite the right side of the equation. And to further isolate y, we have to remove the other factor with y, which is x minus 4. So we will be using commutative property of multiplication, or just divide both sides by that factor. So the left side will become x minus 4 over x minus 4, which is the other factor of y. Then x plus 2 and x minus 4. So we divide both sides by the multiplier of y, which is x minus 4, or factor of the numerator, in order to isolate this y. So we have to cancel this out. It will become 1. 1 times y is just y. And the right side is x plus 2 over x minus 4. And for our last step, we have to change y by f of negative 1 of x. So our final answer is f of negative 1 of x is equal to x plus 2 over x minus 4, which is also a rational function. So we can get the vertical asymptote, horizontal asymptote, x-intercept, y-intercept, range, and domain, and we can also graph this inverse. Our last example, we have again a rational function, that is f of x is equal to 1 minus 5x over 3x minus 4. First step, change f of x to y. So f of x will become y, that is equal to 1 minus 5x over 3x minus 4. Second step is to interchange x and y. All y will become x, and all x will become y. And after that, we have to solve for y. As we solve for y, of course, we have here cross multiply. So let me just cross first. That is x times 3y minus 4 equal to the right side of the equation, that is 1 minus 5y. Then we multiply now the left side. X times 3y is 3xy, and x times negative 4 is negative 4x, equal to just the right side. And after that, regroup all y. All y should be written on one side of the equation. So I am going to write it on the left side of the equation. So my 3xy will retain here, and I have to move my negative 5y, it will become positive 5y. That is equal to what is left on the right side is 1, and then my negative 4x will become positive 4x on the right side of the equation. So that is also the same way with commutative property of addition. So let's continue. We have now 3xy plus 5y is equal to 1 plus 4x. We have to factor out this y. So to do that, we have to remove our y there. It will be written outside, and what remains inside the quantity are 3x and positive 5. And then write the right side of the equation. Now we have to isolate that y. We have to divide both sides of the equation by 3x plus 5 and 3x plus 5 in order to make it equal to 1 and retain y. So the right side will become 1 plus 4x over 3x plus 5. And for the last step, we have to change y to f of negative 1 of x. So we have f of negative 1 of x is equal to 1 plus 4x over 3x plus 5. So this is now the inverse of the given rational function. So as you observe, this rational function can have a vertical asymptote of x is equal to negative 5 over 3. A horizontal asymptote of y equal to 4 over 3. And then an x-intercept of negative 1/4 and y-intercept of y is equal to 1/5. And for our domain, x is an element of real number, but x cannot be equal to negative 5 over 3. As we continue with the range, y is an element of real number, but y is not equal to 4/3. So this is now the solution of the sixth item.